Look at this scary past paper question. It looks like a nightmare, right? But it's actually much easier than it looks. Yet, every single year, thousands of students lose massive grade boundary marks on it. Zero fluff today. We're jumping straight into the examiner's secrets for Cambridge IGCSE Physics 0625. If you've been bleeding marks on practical data and calculations, we're going to fix those painful mistakes right now. Okay, let's dive right in. If you are substituting numbers before you even rearrange the formula, you're literally bleeding marks. It causes arithmetic errors, copying mistakes, it's just a mess. But by the end of this explainer, you're going to perfectly execute the top band method instead, rearranging those symbols first and applying the correct sig figs, securing every single mark from the examiner.
Part 1. Data Processing. Mastering Averages and Precision.
Now, you might think taking an average is just basic math, right? But the Cambridge mark scheme, it demands a very specific scientific approach. Imagine you're in the lab. You collect two measurements for a pendulum length, 81.5 centimeters and 81.6 centimeters. Dropping the ball on processing this raw data is a painful learner mistake that instantly caps your grade on practical questions. So, obviously, we start with the basic mathematical steps. First, we add the values together to get 163.1 centimeters. Second, we divide by the number of values, which is 2. That gives us a raw calculator result of 81.55 centimeters. But here's the catch. Stopping at 81.55 is exactly where students lose their accuracy mark. What's really fascinating is that the final examiner-approved answer is exactly 81.6 centimeters, not 81.55. You have to round it. But why? Why exactly are we rounding to this specific decimal place? Well, this brilliantly illustrates a core Cambridge rule. To quote the examiners directly, the value has been given to 3 significant figures because that was the precision of the individual measurements. See, your average must absolutely match the precision of your raw data. Since 81.5 and 81.6 both have exactly 3 significant figures, your mean must also have exactly 3 significant figures. Part 2. Equation Manipulation. Rearranging before substituting. Escalating the stakes a bit, let's look at how early substitution causes massive headaches. Processing raw data is one thing, but plugging that data into complex formulas, that is where the real exam pressure hits. We all know the classic formula for a spring. Force equals the spring constant multiplied by extension, or F equals kx. But if you're substituting your numerical values directly into this exact expression right at the start, that is a massive trap. The top band framework actually demands that you manipulate the equation in symbols first to change the subject. You need to visually step through the algebra before a single number appears. So if we need to find x, we divide both sides by k to isolate our subject, giving us x equals f over k. Always do this first. Now, in just a moment, I'll show you the exact examiner checklist for plotting graphs that changes your answer completely, but first, you need the mathematical framework that makes that clue obvious. Because without fully understanding significant figures and calculations, your graph data will be completely flawed anyway. So let's see how this builds. Once we rearranged it into x equals f over k, we can safely substitute our values. If our force is 4.16 newtons and our spring constant k is 2.0 newtons per centimeter, we get a raw calculator value of 2.08. But again, you cannot write 2.08 on your exam line. You must write 2.1 centimeters. Wait, why 2.1? Because, as the official rule explicitly states, you must use the lowest number of significant figures from your substituted values. Look at the inputs. 4.16 has 3 significant figures, but 2.0 only has 2. Therefore, the lowest number is 2, meaning your final answer must be strictly restricted to 2 significant figures. Part 3. Plotting perfect graphs. The visual data framework. Okay, now that you've mastered the math and the precision rules, let's unlock that open loop I mentioned earlier and dive into the visual data framework for perfect graphs. Graphs are literally where the most reliable marks are hidden, if you follow the exact procedure. Here is the rapid-fire examiner checklist for setting up your axes to ensure you capture every single structural mark. First, you need about 6 data points, spread over the maximum range possible. Second, use scales that actually use up the graph paper. And critically, place your dependent variable on the y-axis and your independent variable on the x-axis unless you're directed otherwise. The absolute crucial point here is axis labeling. Missing the unit on your axis label instantly caps your grade, no exceptions. You cannot just write time or force. You must write time/seconds or force/newtons.
The name and the unit together are completely non-negotiable.
When you're actually plotting, your data points must be precise. We're talking small dots inside a circle, or a neat little cross drawn with a very sharp pencil. Please do not use giant blobs of ink. And finally, you must finish it beautifully with a smooth line or curve of best fit that actually represents the trend. We are not playing connect the dots here.
Part 4, Examiner Checkpoint, Spot the Error Challenge. Okay, let's put you right in the examiner's seat with an interactive challenge to test what we've just covered. Let's see if you can apply these rules under a bit of pressure. Look closely at this student's final answer. They calculated x equals 4.16 divided by 2.0 and got 2.08 centimeters. Based on everything we just discussed about precision, where exactly did they drop the ball? Take a second, spot the error.
Got it? Here is your examiner-style correction. The inputs 2.0 is only two significant figures. The student left their answer as 2.08, which is three significant figures. That is fundamentally flawed. The perfect answer requires rounding down to 2.1 centimeters to perfectly match the lowest significant figure of those inputs.
Let's quickly recap our entire strategy for securing those top band marks. First, align the precision of your means to your raw measurements. Second, always rearrange symbol equations before substituting any numbers. Third, ensure your final answers match the lowest significant figures of your inputs. And fourth, rigorously follow that 6-point graphing checklist we went over.
So you know exactly how to process the data now. But this actually leaves a massive gap because, honestly, without knowing how to design the practical investigation itself from scratch, like identifying variables and safety precautions, all those data analysis marks we just saved are completely useless. The final missing piece to ensure you secure every single mark is only in our follow-up explainer. Subscribe to our YouTube channel Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. And check out that next explainer immediately to secure your practical design marks right now.